No, use 45. And of course your password. So anyone who cannot visit this page, please raise your hand. Okay. Okay. Okay, so I think I can change the password for you in the next lesson. Okay, anyone forgot the password, please raise your hand. Okay, only 2, right? Okay. Okay, so maybe you can use the. Okay. Do you know how to change the password? Okay, you can use because I've created 50 accounts. So in these lessons, the two of you can use student 35 and 36.
username 使咩 add 㗎
？username 應該唔使，
我就咁 student
應該
點啊？
我睇睇先。
So do you know how to change the password? Okay, so maybe I should go through it one more time. Okay. Okay, so if you first logging into the HPC server, the high performance computing server, you have to change your password through command line. So the way to change your password is to this. Okay, so when you log in, I will use I think 40. So type yes, and then it will ask you for the password. The original password is HPC2025 exclamation mark. Okay, and you have to type the HPC2025 exclamation mark again. HPC2025 exclamation mark again. And then you can change your password. Okay, so maybe I can help you during the break. And I think I should just keep going on. So this is the original password. If you are not sure how to change the password, please refer to the week 1 PowerPoint. Okay, week 1 PowerPoint. So anyone still cannot get into this page, please raise your hand. Oh, okay. Okay, so maybe I will help you during the break. Can you try this? Do you forget your password? No? Oh, okay. Okay, so click Files and Home Directory. Files and Home Directory. The step should be in the PowerPoint slide. You're going to refer to the slides. So click Files, Home Directory. Okay, so this one. Files, Home Directory. Files and then Home Directory. Okay, I will pause here a bit. And then it should be, you should see this page. Maybe you have week 1 materials. Okay. Now I want you to go to Moodle and download the week 2 materials in here. So go to Moodle and download the week 2 materials. So when you click this, it should download a zip file, and then when you unzip it, you can extract this. Okay, you should see a folder pop up. When you double click, you should see code examples and lab. So be extra careful of this step. I repeat once more, be extra careful with this step. So I want you to all first download week 2 materials first, and then go to the file explorer. Okay, so make sure that you are not in make sure that you are not in this week 2 folder. You have to double click inside to see another week 2 folder. Okay. So be sure that you have this week 2 week 02 folder, and if you click inside it, you should only have code examples and lab. So go one level up. So is this week 2 02 folder. Okay. So now I'm going to drag the files to here. Okay, so let me repeat the steps. Make sure that you are not dragging this folder in here. You are dragging this week 2 folder. Make sure that you are not dragging this week 02 folder to here. You double click it so you see this week 02 folder, and you drag this into here. Okay. This is very important, so make sure you follow the steps. So make sure that it is not this week 2. Double click inside, and then you should select this week 02 folder and drag it here. This looks like not very important, but it's actually very important that you drag this 02 folder. So if you drag this folder, you should see something like upload 15 files to the HPC server. And by uploading all 15 files, you should have this week 02. So because today's lesson will be mainly focused on working with the Python file inside this week 02. So I just want all of you actually make this step. So let me just quickly check. So if you forgot your password, please use it. Can you double click the week? Double click and we two people Okay, for those who forgot the password, please send me an email after class or okay, for this lesson, yeah, you really have to have the account. So let me go back to the slides. Okay, so after you log in, the user interface that I provide have this button called terminal, which allows you to actually have access to the terminal. It's the exact same terminal that you'll be using. So if you want to make sure that you have all the folder, there should be no O3 model loading in your folder. So if you're seeing this structure, it should be okay. So let me just do it for the student 45. Okay, student 45. So code examples, if I change my current directory to code examples, I should see O1 Tensor Basics, O2 CPU vs GPU benchmark, O4 memory profiling, O5 data exploration. So for the first one, for the first Python script, it's actually showing you how PyTorch matrix multiplication works. For the second one, we will compare the speed between CPU and GPU. And the fourth Python script is actually helps you to calculate your GPU memory, because this is important because you need to know what model can be loaded in here and what cannot be not loaded in here. You need to understand why that some models are too large for the GPUs and so on. And for the O5 dataset explorations, it is important because you only have 25 gigabytes of memory. If you are going to train corpus, which is open source corpus on the internet, which takes up 3 terabytes of memory, you cannot do it in here. So you have to have some special tricks or data streaming to be able to train your model in a large scale. So this Python script allows you to have a bit of understanding of what is data streaming is. Okay. And finally, of course, you're going to train your tokenizer today. So okay, so today you will be should be able to build your own tokenizer, and this lab 1 is actually for you to build your own tokenizer. We will be going through all the files in here today, and hopefully you will have a basic understanding of what the tokenizer is all about. Okay. So now we will go back to this code example folder. Okay, so okay, so just a quick review from the last lecture. Last lecture we've talked about some basic GPU idea and what is Python. So in Python you see in here import torch, and you have this basic addition operation. And the computer sees this, and the PyTorch library will use a C++ layer to optimize the addition operation. And also, finally, the GPU called NVIDIA provides the CUDA layer for massive parallel
你出
execution.
你出發哦 CD 2點啫嘛
And
跟住再
I assume all of you knows about what a tensor is. So can anyone shout out what is a tensor? Okay, forgot everything. Semester 1 learned. Okay, so tensor is essentially a matrix but with multi-dimension. So a scalar is just a number. So you call a number a scalar. A vector is a list of number in a sort of sequence. So you order them in this way. A matrix is you can think of a matrix as two vectors lining up in columns. So we are thinking in columns. So every time you see a matrix, you do not read it like a row. You think of the vectors are columns. Okay. So tensors is actually a high dimension matrix. So tensor looks like this. So a matrix you have 4 elements in like a plane. So a 2D matrix. A tensor is kind of like stacking these matrices into inside bigger matrix. Essentially, this is what a tensor. So in PyTorch, the way to create a tensor of a matrix is quite simple. Of course, you do not have to write this because you can generate this using AI. So, but I think it's good to understand what it is written for. So, if you are going to create a tensor in GP, a tensor, you just say write torch tensor and then bracket it like this. So you have a list. But please be careful. If you create tensor like this, it will be creating on the CPU. So you have to move all your tensor or matrices into GPUs. So CPU tensors, you can use this function called toCUDA, which will mix your tensor moving to the GPU virtual RAM. If you recall what a virtual RAM is essentially some RAM inside the GPU, okay, or some memory inside the GPU. Or you can create directly on the GPU. You just need to add the device called CUDA. So you write like torch. This means random. A matrix with 1,000 rows and 1,000 columns, and device equals to CUDA. Okay. In matrix multiplication, it uses a special symbols like in your email address is like the and. So A and B is essentially A matrix times B matrix equals to C. Okay. So just a quick refresher on matrix multiplication. I will have a very quick review on just a reminder on how to do matrix multiplication. Okay, so if you have a matrix which looks like this, multiplied by I will make it very simple. A matrix multiplied by a vector. I will just click. So it looks like this. So you kind of move it up into here, and you do 1 times 2 plus 1 times 1 would be 3. And then the other row, 0 times 2 plus 1 times 1 equals 1. 2 times 2 plus 2 times plus 1 times 1 equals 5. Okay, so this is matrix multiplication. You just need to remember how this matrix operation works, there are some deeper meaning of why the matrix operation looks like this. Essentially, it's related to graph and vectors. But for now, you can just accept the fact that matrix multiplication looks like this. Okay. So let me do it once more. Okay. So essentially, this is matrix multiplication. How about if you want to multiply a matrix with another matrix? Okay, so matrix multiplied with another matrix. Because if you recall the structure of transformer, essentially it's just a bunch of matrix multiplication. Okay. So if you want to this one. So you can think of it like convolution neural network, right? You have this kernel, and then the kernel sliding down into here. Let me repeat the steps. So you can think of it, this is a kernel in CNN, and this is a matrix in the, you can think of this as an image. So when you have a kernel, you slide out, just do the matrix multiplications. Okay, so this is one way to understand matrix multiplication. Of course, you can remember the matrix multiplication by force. So always is the first row multiplied by the first column of the matrix will get you the first element, the first left-hand corner of the element. And for this number, it is always, okay, let me change. Let me give it some. Okay, so for this number in here, how do you get 6? Essentially is this one multiplied by this one is 3, this one multiplied by this one is 2, and this one multiplied by this one is 1. And then you add all the elements up. So it's 3 plus 2 plus 1 is 6. Okay. So how do you get this element 12? Anyone answer how to get this element 12? Okay, so let me have, so how to get this element 12? Anyone thought that in order to get the element 12, we need to use the first row? Please raise your hand. No. Second row, please raise your hand. Third row, please raise your hand. Okay, correct. Okay, so for the second matrix, which column should I use? Okay, the second one. Okay, great. So let's test. Let's test this again. Okay, so we have to reset this. So let's, I think, add one more column. Okay, so how do I get the element 11? Okay. Do I use the first, for the first matrix, do I use the first row? Please raise your hand. Okay. First row. first row.
四行變
Okay. First row. Okay. For the second matrix, which column should I use? Okay, second. Good. 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 Okay, so let us do a. Okay, how do I get this 10
頭
element?
四個唔係四個
How do I get this 10 element? So for the first matrix, do I use the first column or second column? First column, first row, sorry. First row or second row? First row, okay. For the second matrix, which column should I use? I heard fourth, I heard third. Third, please raise your hand. Third. Okay. Fourth, please raise your hand. Fourth, anyone fourth? No? Okay. Okay, so is this row multiplied by this column? This row multiplied by this column. So it's the first row multiplied by the third column. Okay. So
第三
should I do one more example?
先打橫咦
喺左前字，喺左前字，我左前俾佢咁樣先嚟講。
Okay, so
第
just curious.
呢個
What
數
the dimension
即係
of the matrix if I multiply by a 3 times 4 and then 4 times 4? What's the dimension of the matrix? So how many rows do I get for the output? How many rows do I get? So do I get 1? Please raise your hand. No? Okay, that's good. Do I get 2? Raise your hand. That's good. How many rows do I get for the 3? Raise your hand. 4? Raise your hand. 4? Anyone 4?
應有
No?
佢問你回收幾多？
Okay.
呢啲唔係四個
Okay. That's great. Are you guys cheating? Okay. So how many columns do I get for the final matrix? 4. Okay, that's great.
4乘4嗰個時，應該4乘4。
Okay, so I presume all of you understand what matrix multiplication is. Okay, so that's great. So because of tensor, you do not get this simple relationship of only like a 2-dimension matrix. You get multiple dimensions, like you have 10 multiplied by 20 multiplied by 100. This means in a tensor, you will have a matrix of 10 by 20 and over a dimension of 100. Okay. So this is a fairly quick way to understand the dimension of matrix using graphs. Okay. But I do not think we will go too deep into this one. This is just for your references. It's just a fairly quick way of knowing the output dimension, because in here you can directly understand if the first matrix is 3 by 4, and then multiply it by a 4 by 4, you get a 3 by 4 matrix. Okay, but in tensor it's slightly more complicated because there are different dimensions tensor. But you can use this graph to simplify the dimension. This is a bit complicated. But in here, I think for this course, I think if you understand this well, I think it is fine. So let's try to run our first script to check if we all on the same page. So record the first lesson. You need to go to the directory first. Let me clear the screen. So this command like change directory to here. Make sure you're in the right directory. Okay. So this one will be changing your current directory into the code sample. And of course, the second line is to make sure that the script is executable. So change mode plus X run single is a script that I've prepared so that you can run the Python script fairly easily. Okay. So if you are interested in what is written in run single, you can just check it out in the UI browser as well. Okay, so this is the script. Essentially, it's asking for the HPC server, some GPU access, and the variable script will be, so it will take in a variable, and the variable will be the script name, and it will try to execute the script. Okay. So record sbatch in the last lesson. Sbatch allows you to run any script with a queue. So you can actually copy this line and try to run the job. So sbatch is submitting your job to the high performance computer. This line is actually setting the variable script into to O1 tensor basic. So I'm using this script to run this Python script. So I have submitted a batch job 80. Let me check the queue. Okay, so I'm seeing job submitted 84. Okay, that's good. So after executing the script, you should see something like there should be an auto directory inside your code examples. So if you click into the code examples and check out week 280, you will have your results. So these are some matrix multiplication done in PyTorch. You have a 1D tensor, 2D tensor, random tensor, 3x4, 2x3, and okay. And there are some simple Boolean mask matrix operations. These are for transformer. Anyone record there is a mask layer in transformer? Okay.
應該喺個模塊先睇到，應該係呢度。
So there is a masked multi-head layer, attention, and there is a non-masked multi-head attention layer in the transform. So in here, you will have a mask, something like tensor, which allows you to do fast matrix multiplication. Okay. But in mathematical terms, you do not see this tensor because it kind of do it written slightly different in slightly different mathematical notation. But when you're actually coding, it will be slightly different. So if you are doing byte coding in Python, please be careful that you are aware of these kind of operations. Okay. But we will go through these step by step when we get to that. Hopefully all of you have run the script successfully. Anyone have trouble running this script? Okay. So, okay, anyone have trouble running the script? Okay, only one? Okay, can you find a group mate to help you? Okay, if only one student having trouble running this script, I think I should carry on. Okay, so that's great. So, now we are going to test our GPU speed. So let's try to run another script. We are going to test the speed between the CPU and GPU. So the task is to multiply two matrices together. Each of them have 10k elements for the rows and 10k elements for the columns. And this is about a trillion operations. Remember the matrix multiplication that we do? So you have to do adding and multiplying and get only one number, right? So, so we are going to test the parallel processing. The computers of the CPU is 32 cores, and the GPU CUDA that we have is around 2,000 cores. So this is the testing script. Okay, so we initialize the CPU matrices using torch rand, which means random number with a size 10k. And then we do high torch CPU multiplication. So CPU A, matrix A multiplied by matrix B will get you the C CPU. Okay. So and then we will time this operations, and then we will do the same for GPU. So make sure that you have, when you are creating matrices in GPU, it is device equals CUDA. Okay, so let's run the script first. So in order to run the code, it is in the slide 58. So you make sure that you change your directory to the Go folder and copy this command. So you will be this should be familiar because you are just changing the script variable to the your Python script. Okay. So let me just simply copy this as batch. Okay. So let me have a quick view of. Okay, so you are seeing queuing and because you are submitting jobs simultaneously, so there should be some queuing. But I think the HPC handles the request quite good. Only one is queuing.
呢張就見到12張，即係見到成日即係8分。
Meanwhile, I will explain the code that we have just run. So this is the output of the O2 CPU vs GPU benchmark. We are testing first not that large matrices. So we will have CPU multiplying size of this matrix together, and we see the GPU speed is around here. So only takes minus very few processing time to achieve the matrix multiplication. So let me go to the so it speeds up around 13 or 14 times. When I do the test, I actually achieve 13 times speed up for the GPUs. And let's
呢個就係想睇下啲 job。
So we can view the results in the output folder and your job ID. And of course, there is some memory transfer overhead, which means if you are doing transferring CPU to GPUs, there is some memory usage. Please make sure that you avoid this kind of transfer. If you are doing initializing matrix, make sure that you first initialize the GPU. Okay, but there are some concerns of memory usage if you are using a batch. If you are just testing, please use you can use CPU for your tests. But if you are doing a large number of data testing using batch, GPU is much faster. So while it is running, I will talk about how to calculate the memory or memory usage of a matrix. So when you're doing a estimation of how much memory that will be used by the GPU, we have to know how many bytes that it will take up if for one element. Usually, if you're using flow 32, each element will be taking up 4 bytes. So for a 10K rows and 10K columns matrix, you should be multiplying all the elements by 4 to calculate the number of bytes. There is a slight catch for if you are converting bytes to gigabytes. It is not straightforward that you divide it by 10 to the power of 9. So if you are doing the converting, please use a tool for you to convert because it is slightly different. So let me show you how to convert between bytes and gigabytes. Okay, so when you're converting bytes to gigabytes, you need to divide by this number. This number is actually, sorry, I think it's this one. This number is the number of bytes in gigabytes. You might wonder why it is not that straightforward reducing the amount of 0 to 10 gigabytes because it is measuring in binary system. So the number of bytes is I think 2041 times to the power of 3. So the number of bytes, let me check. Yes. So the number of bytes in gigabytes should be 10424 to the power of 3. And this is just, I think, a standard that you might have to remember. Or you can have it like to the power of 20. So this is just one thing that you have to aware of when you are calculating how many gigabytes that a matrix of this size will take up in the GPU, because GPU memory usually measured in gigabytes. Okay, so when you are doing the test, you might wonder why the matrix multiplication took up more than the matrix itself, because you have matrix 1 multiplied by another matrix, and you still need some memory for the results matrix. And also, when doing the multiplication, the CUDA library actually used up some space called CUDA list. It's more like a draft paper for doing the matrix calculations. So just a simple matrix multiplications will take up, of this size, will take up around 1.5 gigabytes. So when you are thinking of running your transformer model, so when you are thinking of running any sort of model, you need to understand how many matrix multiplication required for you to, so the number of layers you have to kind of estimate before you're actually running the model. So estimate the number of matrix multiplications and also the number of layers as well. Okay, so a 7 billion parameter model at a floating point number of 16 would take up approximately 14 gigabytes, but you need 18 to 20 gigabytes to actually run it because of all these matrix multiplication that you have seen. Because it needs some space for the drafting and also some space for the results. So it's actually bigger than you need if you're actually running the model. So make sure that you plan some buffer for the model size. And furthermore, PyTorch optimization, PyTorch memory strategy will also reserve more memory than actually used it. And make sure you clean up the memory allocation to avoid some memory leakage. Okay. So the key takeaway is to make sure that you initialize your model in GPU and also aware of using too large batch size when you are actually running the model. Okay, so the main takeaway is actually do memory estimation before you're actually running the model, and always keep your data on GPU. So here are some references on how to shrink down your model. Remember that the matrix multiplication, each element takes up 4 bytes. You can actually reduce each element to 2 bytes, or to 1 byte, or to 0.5 bytes. So it will actually drastically reduce the size of the model, but you trade off the precisions. So the results might not be as good as you think, but if you have some, if your GPU cannot handle a large model, it is one way that you can reduce the size of the model and fit inside the GPU. Okay, so a 7 billion model with 4 bytes each element will take up to 28 gigabytes. With 2 bytes each element will take up around 14 gigabytes. With 1 byte it will take up around, I think, 6 to 7 gigabytes, I would say. And you can, I do not recommend using integer 4 because I think it will drastically reduce the performance of the model. But if you really want to run a large size model, and you can kind of sacrifice all the precisions and still fit inside the GPU. So for your project, I think 14, if you are running the GPU, I think taking up 14 gigabytes might be fairly comfortable. Okay, so any question? Okay, if no other questions, I will, I think I will take a break here, and I will let you ask questions during the break. I believe there are so many questions. Okay, so